So I'm chief scientist at Sophos. I run everything to do with machine learning at Sophos, and the team I manage also does a lot with sort of big data, cloud architecture, and that kind of thing. And my talk today is entitled "No More Secret Sauce: How We Can Power Real Security Machine Learning Progress Through Open Algorithms and Benchmarks." Okay, so I'd argue that the way we do machine learning and security today is closed. Most companies don't publish the machine learning approaches that they use on their products, or they don't publish all of them. Even when we do publish, because we have very few public benchmarks by which to measure our approaches, results are really apples and oranges. It's hard for me to tell whether or not my team's malware detector works the same, better, or worse than Microsoft's or CrowdStrike's, because when we publish papers, they are on different data sets. We're measuring our results differently. And because we don't have much openness in machine learning and security, we take the easiest path to understanding what everyone's doing, which is we just sort of scrutinize each other's watered down, semi-technical blog posts, and that's how I think most of us in the industry make sense of what we're doing relative to our competitors. Now that might seem normal in a competitive business environment. But there are examples of other subfields within machine learning where folks are doing things very differently. So in the domains of, say, machine vision and machine learning-driven natural language processing, companies really do tend to publish their machine learning. They assess their methods via common benchmarks, so you can actually tell who's got the best model, and then companies cross-pollinate as a result of that when they see that another company is doing something that's more efficacious. Their researchers often do exchange ideas via scientific papers that measure proposed methods based on common benchmarks. And as a result, I think there's just dramatically less cynicism about these companies' ML efficacy. Now, companies like Google and Facebook that publish heavily and publish algorithms measured against common benchmarks, so we can verify that their methods actually work in the way that they say they do. There's definitely cynicism about their machine learning methods, but it's not about their methods' efficacy. It's around issues of privacy and other issues like that. I think the public tends to believe these companies when they say that their ML is efficacious, and I think that ultimately trickles down from the fact that they are scientifically honest and their scientific infrastructure, like benchmarks, that allow their results to be mutually compared. So I want to argue today that the way we should be doing machine learning and security is open. I think we should have similar technical standards around machine learning as we do with, say, cryptography. If you're claiming to be using a cryptographic algorithm in your product, hopefully you can name what that is and point to a paper that describes transparently how it works, and customers can rest easy that that algorithm has been peer-reviewed by academics. And I think we should take that same attitude when it comes to claiming we're using machine learning in our products. I think we really should be publishing the approaches that we claim to be using. I also think we need to create a technical culture in which ML component performance should be measured against public benchmarks and reported, just in the same way that car manufacturers report their miles per gallon, right? You can have openness around component efficacy in a competitive capitalist environment. There's lots of examples that we can draw on there. Of course, we should compete, but there should be healthy cross-pollination between security data science teams at competing companies. That's how machine learning is advancing in other areas, and security needs to take advantage of that as well. And I think the stakes are really high in opening up the way we do machine learning and security. If we keep going down this closed path, it's going to be impossible to measure whether we're making progress. I could tell you whether or not my team has made progress against problems like phishing detection or detecting malicious command line invocations, but I really have no sense around whether the industry is progressing because we don't have common benchmarks and we tend to be closed about our research, and that's just not good for business when it comes to protecting our customers as an industry. We don't know what ideas are working and what aren't, so it's hard to cross-pollinate between teams. I think there's an ethical imperative that we do that so we can make more progress. It's been a well-known problem for a long time that while security companies advertise their use of AI, users are increasingly cynical about that because we use lots of baseless marketing claims. And ultimately, we have to fix this problem if we're going to make progress, I'd say. we open things up, I think we'll sort of invert all of those problems, and I think we'll be able to make a lot more progress. Okay, so I want to talk about the success of OpenML and other areas of technological endeavor as a reference point for how we might proceed in our machine learning subfield, being security. So outside of security, benchmarks have both told the story of progress and also made the story of progress. In that benchmarks have catalyzed open research and idea cross-pollination between competing companies. So here's a time series plot of 4 different benchmarks. 2 of them are in computer vision and 2 of them are in natural language processing, and you can see the story of progress given state-of-the-art machine learning methods against those benchmarks, and you can see them surpassed by, at least some definitions, human performance in the second half of the last decade. Benchmarks are useful in telling the story of progress, but they also allow papers to be lined up against each other and compared roughly based on their efficacy against those benchmarks, and ultimately they draw researchers' attention to the most efficacious methods and allow fields as a whole to progress. It's a widely held opinion in machine learning that benchmarks have been the reason that there's been a revolution in natural language processing and computer vision over the last decade. One very famous benchmark is Imagenet. This is a data set of millions of images labeled by Mechanical Turk workers, and it's widely credited as just leading, as just catalyzing the revolution in computer vision that we've seen in the last decade. Here's a more detailed look at the Stanford question and answering dataset benchmark, and you're seeing lots of papers and the results against that benchmark plotted together. This is something we really don't have in security. We really can't compare methods on a common map, and it's something that we really need for the reasons that I've been saying. All of this work trickles down into products. So Google posted a blog a couple of years ago on how they're using a new formalism in neural networks called a transformer block, and using that in their search application. And transformers in neural networks have been developed jointly by academic labs, Google, Facebook. All these companies are publishing on how transformers work, originally on natural language signals and later on images. And as a result, downstream you get better products for users, like improved search, or like improved object detection in self-driving cars. So I think we really have a choice on our hands. Are we going to continue down a closed path in security machine learning, in which we get sort of B-movie Hollywood's advertising schlock offered by companies and not much else in terms of security ML efficacy, or are we gonna imitate the rest of machine learning as a field and develop standards around publishing the algorithms we're using, measuring them against common benchmarks, and showing efficacy in a scientifically defensible way? And obviously, I think we need to go down the latter path, and I think this is going to mean some real cultural changes among our community here. All right, so where do we go from here? I think we need to be developing benchmarks that give as much coverage as possible over threat models like the MITRE attack matrix, for example. On my team, we're trying to make a contribution in this direction. We released the Sorel 20 million malware dataset this last quarter, and what Sorel is a dataset of about 10 million malware binaries with robust labels amenable to machine learning, both training and evaluation, and also enough metadata about 10 million benign examples that you can reasonably train binary classifiers on the malware and benign-ware and evaluate it against this benchmark data set. This is a large-scale data set with when you have on the order of tens of millions of examples, you can really train industrial-scale malware classifiers and detectors, and then you can compare them against the same benchmark. So this is our effort at creating a data set like Imagenet or some of the other data sets that I showed in the previous slides to help us advance this as a field. We try to publish all of the models that we release, but we're only one organization, and it would bring us nothing but joy if other organizations made the same commitment to when they ship a machine learning model, they publish a scientific quality paper on the model. So again, I think the stakes are pretty high here. I think we need to open up around the way we're doing machine learning and security. I think the dividends of that are pretty substantial. So openly tracked progress, so we can actually say whether as a field we're advancing against problems like living off the land detection, phishing detection, malware detection. Clear signals around which machine learning ideas should actually be built upon versus which should be left in the past, because we'll have evaluations against common benchmarks. Puncture the bubble of vapid marketing hype. So as we get towards a more scientific culture around machine learning, I think we can really build confidence among security product users as to the efficacy of machine learning. We know as security vendors, and I think as testers also, that machine learning is an essential ingredient of detection and security today. We need to prove that to users, and I think the way we do that is by creating an open culture. And finally, I think by opening up our technical culture around machine learning within security, we'll be in a better position to exist in dialogue with machine learning as a whole, which within technology, machine learning is just this juggernaut, the major engine of progress in our time, and we want to harness ourselves to that by creating a sort of a common scientific culture with machine learning researchers outside of our field as well.